Wait, so you said that the minimum is the lowest whiteboard on what graph?
Would depend on what they're talking about. So if they say, where does F have a minimum? It's where it's the lowest whiteboard in column.
So the
Again, it depends on how they say. They said, where does F have relative? That's where F changes. The relative min definition is on this whiteboard. Relative min is talking about is that relative min.
The prime when it's negative, it's like over. That's exciting. This is asking us to realize when it's so we're trying.
Look at me 1 second. Everybody needs to hear this question that Macy asked. Okay, you all want to hear the question that Macy asked, so you do not step in a trap on the test. So because Macy hit the golden question, you all get a free hint at the test. Like, I don't remember to tell all my classes it, but you asked the question, so like I want to answer it. Here's her question. She said, would they ever give a formula for F? I'm not saying the test question is identical to this, but if you understand this idea, it's going to help you. Would they ever give a formula for F and then say, find the minimum of F prime? And the answer is, yeah, Jay's like, of course they would. That's all they do is stuff to mess with us. So hands up. I don't want to do all the little steps. I just want you to be able to tell me the big step. Like if I want to find where F prime has a minimum and all I have is the formula for F, what do I do? What do I do? One step at a time, we'll rotate from person to person. So what's the first thing you would do?
Get the derivative of F.
You'd find the equation for F prime. So I go find the equation for F prime, whatever that happens to be. I'm going to find that equation, whatever that is. 2 points for take. Great, then what would you do? I take a derivative of this to find F double prime.
And then you make the term the double prime.
Because I'm using this relationship. F prime, positive, negative, increase, decrease.
Infinite, right?
See, F is, let's gotta do something here. F is related to F prime in the same way that F prime is related to F double prime. So I'm trying to find out where F prime is lowest. I want to see when F double prime is negative. So I make a sign chart of F double prime. So a sign pattern chart. So the problem doesn't change that much. You just have to keep track. It's just the same thing again. Keep track of what we're talking about. F prime or F double prime. That's all. Don't slip into just doing steps. Question? You got a different question? Please. Sorry to make you wait. They never. Oh yeah, they do that. Sure, just whatever. It doesn't matter. Yeah, it doesn't matter. You just keep going. There's no end.
Got it.
What's the highest prime we have to work with on the test?
13.
No, good question. I don't really worry about it just because it's nothing changed. You just keep doing it. The worst I've seen is I did see a multiple choice question once where they asked for this.
Not a fan.
It's no big deal. You just
There's just so many more work.
how much work depends on what you start with. So. Please.
Is there any way to abbreviate the number of primes? So if you like write, instead of writing F primes and writing the tick 4 times, could you say add and then put like 4 and then a prime sign? Okay, that
sorry.
With the
There might be other, I don't know, because it doesn't happen very
other
often.
things, 15, sure.
Okay, here we go. Okay, look up. We're supposed to figure out when the graph of f is decreasing. I do not have a graph, so when I don't have a calculator or a graph, I use a sign chart. I tie it to Danica's chart. Simple. F will be decreasing whenever f prime has y coordinates that are negative. So I know that I need a sign chart for f prime. Therefore, I need a formula for f prime. So, find f prime, go.
Should we tell you our answer once we find it?
Give everybody a chance so everybody can think. So,
I already found it.
that's good.
Dave, stop being so big.
Find f prime, please, go.
E to the x 2x plus x squared How's that? Is that right? I did the entire thing in my head.
And then you can pass throughout the e to the x.
No way, I did it in my head.
Okay, or x to the x. And then it would be. So did you pass?
So I want to do a sign chart.
X to the, did you get this?
Oh, we have a shopping list tomorrow.
And then you won't do it this one because you really don't know. That's when you can't be paid. Really? You don't have to write this every time. Right in there. I would say that. Right there.
So,
This class,
I just
I like it.
is it anything else you
Don't eat it.
So you did get to this point. What did you do?
Did you pass
No, it's not.
I don't know if this, you know, anchor mechanisms are failing.
Heads up, who has that on the paper? Who has that written on the paper? Show me.
Oh, what? That one?
Yeah.
I factored
Okay, I need to make a point, that's what I'm starting here. Who has this, or if you factor it, it's fine. Who has this? 2 points, okay. Look. Okay, new idea here, new idea, listen close. Okay, when we are creating a sign chart, on the last problem, we created a sign chart, but we were only making one row of a sign chart because we could not break this into smaller pieces. If we try to make a sign chart with this, it's a little bit tricky. It's just a little complicated. So it's smarter to divide f prime into multiple small pieces. Then you can analyze each little piece more easily. Okay? But caution, when you're comparing signs, positives and negatives, you don't ever want to make this kind of a comparison. You don't want to identify that this piece is positive and then identify that this piece is negative and try to add them. Because if you're trying to figure out if a positive plus a negative, do you know the result?
It could be either.
It could be either.
Or 0.
Or 0. So, warning. First of all, if you're ever making a sign chart and you're like, I don't know what I'm doing, I just know this is what you do, stop, okay? Stop. You're headed for a terrible test score. Don't keep going down that path. Come find out. Okay, don't just keep going, okay, I'll just get a bad test score, better too. Doesn't help. Stop and come find out. Look, you're building a sign chart, you don't know what you're doing, stop. If you're building a sign chart and you realize that you're adding signs, you're also in the wrong place because you can't add a positive to a negative and know what you're going to get. So don't ever add signs on a sign chart. There are cases that do work. They just don't always work. So we just don't ever use them. What we always use is multiplication. A negative multiplied by a positive is always a negative. There's no ambiguity. Division also works great. So we'll do this all the time with sign charts. We just don't ever want to do this. Like you ask me a question, I come look at your work. Often the first mistake I notice is you're trying to build a sign chart by adding. No, it doesn't work. Question. Okay, so I want to break f prime into pieces. Focus. I want to break f prime into pieces. But I do not want to break it into pieces that are adding. I want to break it, right, Samuka? I want to break it into pieces that are multiplying. So that's why we factor. So factored, we have this. Question. Okay, now f prime can be identified as 3 separate factors. So when we build a sign chart, we build f prime 1 factor at a time. So we take the first factor x. Oops, let's do this. So we're trying to build a sign chart for f prime. But f prime is made up of x multiplied by e to the x multiplied by 2 plus x. So as the problems get more and more complex, the task does not become harder. You just have more rows in the chart. The analysis is still easy. Talk to me, Lou.
I just got lost when you said that. Started drawing
You're good.
the chart.
So are you okay that this is f prime?
Yeah.
Okay, what we're really doing is we want to take values of x. We want to plug them in here, here, and here. And figure out the positive, negative, or 0 of f prime. Are you okay with that?
Yeah.
What we're going to do, though, to make the task easier is instead of doing this computation all at once, we're going to do each computation separately. For example, I'm going to say, if x is 0, and I plug that x in here, this will be 0. So I'm going to put a 0 right here to remind myself that when x is 0, this factor has a value of 0. I'm just temporarily not worrying about these two. I will eventually, just not yet. This one here, memorize. E is 2.7.
It's 1.
We don't care about that. 2.7 to any exponent is always a positive value. You must have that memorized. 2.7 to any exponent is always a positive value. So this entire row, I don't care what value of x you plug in here, the value you get out of the computation will be a positive number. Anyone want to talk more about that? Please, Darby.
Does that work for any constant that's set
Any
to?
positive constant.
Okay. What about if it's a negative constant?
Negative constants are squirrely because they just,
If it's an odd exponent, then it's going to be not
yeah, you get this weird behavior.
Okay, but if it's a positive constant and it's set to any number, it's going to be positive, right?
Yep. So watch. 2.7 cubed. You tell me. You can. Darby can help. 2.7 cubed, positive or negative?
Positive.
Try this one. Make sense of it. 2.7 to the negative 3.
Positive.
Just a fraction.
Because it's just a fraction. It's 1 over 2.7 cubed. So any positive number, the result is positive. Any negative number just becomes 1 over, still positive. The only other possibility is the exponent of 0,
Which is 1.
which is 1,
Which is still
which is still positive. Please.
If it was like a number to even exponent, does that mean it would always be positive?
Any positive number to any exponent is always positive. Any number to an even exponent is positive. Yeah. Oh, back to here, look. Okay, back to Malia's question. So what we have figured out is if we plug in any x into this right here, we would still be plugging that same x here and here. But if we're just kind of looking at this part, we know this part's going to have a positive result. You with me? Let's go here. You always want to start with these zeros. So the value of x, which will cause this to equal 0, is -2. Right? Label that. It's really critical you have good vertical alignment. That's why I'm drawing these little vertical lines. It's where mistakes occur. So 0. So the chart says, if you took this formula, one second, and you plugged in -2, this part of f prime would have a value of 0. Sam and then Malia.
So, just to clarify,
I'm reading the question and trying to apply it to what we've been doing, which I kind of get. And it's asking, the question is asking like, what part of f is always decreasing, right? Okay. I think I get it.
You're good, Malia.
So you said that e to the x will always be a positive number, or if the x is a positive constant, whatever you said. But
You can
on
memorize
the-
the shortcut. The shortcut is e to any exponent, always positive, never 0.
Yeah, so then on this little like number line thing that you drew, isn't there some negative numbers on there too that you wrote positive? Like,
I think what you're doing is mixing up the x and the y again. It's okay. These are the x values. So right here is an x value -2, x value of 0, x value of 5. If I plug 5 into here, I'll have e to the 5th. Would that be a positive or negative value? Positive. So this positive sign right here is y value. So when the x value is 5 plugged in here, this becomes a positive value.
so what
these
about like the -2?
So this -2,
Yeah.
I'm going to plug it in here. What's e raised to the -2 power?
1 over e squared.
So
Oh, yeah.
1 over e squared, is that a positive number or a negative number? Positive.
Oh,
So that's why here, look, when the x value is -2, plugged into this, the y value is a positive value. Was that your confusion?
yeah, that
2
was-
points. Okay, look. Look here, look. To fill out the chart, we want to plug in negative numbers into this piece of f prime. It's really easy. Any negative number plugged in is negative. It's just x. So these are all negatives. Don't make a plus there, it'll mess you up. Okay? We good?
Then what if the ones on the other side all the positives?
Positive, sure. You're just plugging this value into this. So, questions there? Please.
So, does that mean that anytime the number is, the x is below 0, it's going to be negative? Or?
So you're making it more I can't talk. You're making it more complicated than you need to, but it's really simple. You're taking this number, you're plugging it in here. So -2 plugged into here is -2. So -2 gives me a negative result. If I plug in -5, negative result. Is that your question?
Okay, and then we go to the...
So now go to here. Just plug something in. -5.
Negative.
2 plus -5 is a negative number. So they're all negative.
Wait, but if you plugged in like -1, then...
Negative one's
Oh,
over
but
here.
that's past...
Yeah, 0 is the boundary.
Yeah, got it. Never mind.
0 is the boundary.
I think I get it.
Go
Can I go to the
Tit.
next step?
Hold on a second. Yeah, just 1 second. Okay, look at me. Okay, here's the dangerous part of this method. It seems oh so simple when I'm just up here drawing stuff, but if you're not following what's happening, you can't do it on your own. I've seen it before. So does anyone have anything they want me to say again or different? It's not complicated if you follow the reasoning. These are x values. You're just plugging those x's into these formulas. You're just making a table like you have for years, except you don't have to worry about the numbers. All you care about is positive, negative, or 0. So pretty good? Okay. We test over here. If you plug in a 0, this would be positive. So let Sam go, and we'll just kind of see where we go. Please.
So, if I'm looking at this correctly now, because we have all three of the factors being multiplied into the final number of f prime, does that mean we're looking for the spot where it would turn out negative, right? So that means anywhere before -2 would be positive, because the two negatives would multiply to be a positive times positive. And then anything after 0 is just all positive. So the only place that would qualify as a range to answer the question would be -2 to 0, right?
Which is
Yes.
B.
I get it.
Yeah, let me say it back just differently, just to help. It's perfect. Listen, hey. Here's what's happening. Look at me. Look at me. Don't check out. Look at me. We are trying to figure out what this is. Okay? We are just doing it in 3 little pieces. Make sense of this. Right here, x is about -5. So I'm going to plug into all 3 of these x's -5. But I've already figured out that this piece right here, when x is -5, that's a negative number. That's why I wrote that down. So you don't have to keep track of it all in your head. Well, when x is -5, this piece is a positive value. So I wrote it down. This piece is a negative value. I wrote it down. But those 3 pieces all multiply together. So the negative times the negative is a positive, times a positive is still a positive. So I figured out that when x has a value of -5, the y value of f prime is a positive value. It's called a sign pattern chart because you don't have to check every single number, you just look for the patterns. So like Sam saw very nicely, this whole block behaves exactly the same. Just like that. I go to the next boundary. The boundary is right here. So if I'm plugging in x equal -2, I've already written down this factor of f prime will be 0. The other 2 will be a positive and a negative. Who cares? 0 times whatever will be 0.
Still not like not.
Okay? Question. You would need to say things differently or again. Okay, look up for a minute. Hey. Hey, warning. Look up. Okay, look up. You can staring at the left there. It's all good. You're drilling down there. It's an evil look. Okay, caution for everyone. Here's a place where I've seen errors occur on tests. You're rushing, you make your sign chart too narrow, and right here you'll put a 0 right next to a 0, and you'll forget. Between these 2 zeros there are values. That's a common mistake. Watch out for that. You've got to figure out what's happening between the zeros. Okay? Seen that happen on tests a lot. Correct answer here is no. Those are the x-coordinates where the graph of f will be decreasing. Because those are the x-coordinates where the graph of f prime has negative y-coordinates. Question? What's that? I always have to check what's going on at home. something happens and I can't be here, but just watch for this happen.
But then it's something.
Kenzie, you asked me a question earlier, was I think which one?
21.